Hi, welcome back. We are going to the second lecture of this series of multistage amplifiers. So let's have a review of what we have seen earlier. So this one I have explained to you. Now I'm going to perform AC analysis for this circuit. Now when I say AC analysis, the first part that we are supposed to do here is we have to make this as a point. This is very important. So when I do AC analysis, the first thing I am supposed to do is I have to short all DC sources to ground. That's the first one. Now, second thing that I'm supposed to do is short all capacitors. The third thing, open all inductors. So these are all the three important things that we are supposed to do. Now let me go ahead and do the same for this one. Now coming back to this one, so if I say I'm going to make a certain modification in the circuit. So now first thing what I'll do is I'll override with the red color. Now first step I'm supposed to do is short all the DC sources to ground. So what I'll do is, this is the DC source that I have here. I'll replace this with ground. Okay, then short all the capacitors. Now whatever the capacitors I have, I'll short them. I've shorted all the capacitors. Right now open all the inductors. Now we don't have any inductor here, so we don't have a problem. Now what I'm going to do is I'll redraw the circuit. Now let's see this. So what we had, so first we'll have this input supply, that's the VS, and then the resistor, current limiting resistor, then the capacitor that was here is already shorted. Then what do we have? We had R1, one end is again getting grounded, and then we had R2, this is also getting grounded. So this VS or VN is here. Then next we had the capacitor here. Now again, if you see from the previous slide, see here a short that's in parallel with RE. So the net resultant is only short. So now that's why I'm removing it and writing here. Then next part is like RC2 we had. There also it was connected to VCC, that is done. And then we had this. Here we had a capacitor that is again shorted now. The second stage again we had R3, and then we had R4. Now again we have replaced the VCC by ground, so this is also grounded. Then probably the same logic what applied here, here also it is applied, so it is shorted. Now we had here RC2 as a grounded, and then that was connected via a capacitor that is also shorted now, and it goes to RL, that's getting grounded. Now we'll write the important points here. See, first point, let me check with this one. See, these two are in parallel, right? So we'll write it. First, R1 is in parallel with R2, correct? So that's one part. And similarly, coming back to this one, similarly here also, if you see, R3 and R4 are sharing two common points. One is this one, the other one is ground. So R3 is in parallel with R4. So that part is also done. And then coming back to this one, see, RC2 and RL, they are sharing two common points. One common point is this one, and other one is the ground. So that is RC2 in parallel with RL. So these things are done. Now let's go ahead and draw the hybrid model of the circuit, right? So when I draw the hybrid model of the circuit, first, in fact, I'll go ahead with simplified hybrid model. So because we'll not have much impact of the HOE or HRE on this. So we'll go ahead with simplified hybrid model. So let me draw the simplified hybrid model here. So first we are having Vs, so I'll draw the Vs term here, right? And then what do we have? We have Rs, so Rs is drawn here. After that, R1 in parallel with R2, so let me draw that, R1 in parallel with R2. Then next one is we have this transistor. Now let me replace it with the simplified hybrid model, which means that I'm going to consider only the input impedance term, that is HIE, right? Let me say the current that is moving through this is IB. Then the other one that we have is like HFE 1 times IB1. So here let me say this is HIE1. So that's going. Now this is a common emitter configuration. So this is the emitter terminal that is grounded. So similarly we are grounding the emitter terminal. This is the base terminal, and this is the collector terminal. Then this part is done. After that, what is happening? After collector, RC is getting connected to the ground. So let us draw that. Now you see RC1 is connected to ground. Then after that we are taking it and connecting it to R3 in parallel with R4. So let me draw that. R3 in parallel with R4. Then after that we have the input impedance of this second transistor. So let me draw that. Same process, we'll have only HIE2, that is the second stage input impedance. Let me say the current that is moving through this is IB2. Then after that we'll take it here, and then we'll have HFE2 times IB2. That is also done. Then what else is left out? RC2 in parallel with RL. So let's write this one, RC2 in parallel with RL. Okay, so let's mark these things. So this is IB1, this is IB2. The current that is coming this side is IC1, and then this side what is coming is IC2, right? So this is emitter, this side is also emitter, everything is grounded, right? So for operational comfort we can also draw like this. So this is how the hybrid model of a two-stage RC coupled amplifier is drawn. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.